All, welcome to Satpathy Academy. This is lecture number 3 in the series of lectures on pointers in C. So today we are going to discuss some pointer jargons. Jargons means code words. That's the dictionary meaning of jargons or code language. And memory required for a pointer variable. Right. So that's what we will discuss. So let us say I have this statement here, int star p. So how can I interpret this statement, or how can I read this statement? I can read this statement in 4 ways. First way is p is a pointer of integer type. P is a pointer of integer type. Second way to read this is value stored at address in P is integer. Third way to read this is P is a variable which can store address of another variable which is of integer type. And fourth way is P points to integer type variable. So that is how you can read this statement, right? So now let us see the memory requirement for a pointer variable. Right? So let us say I have this integer type pointer here, int star p. Then I have let me take one integer type variable also. So a is integer type variable. I have another character type variable, char star q, and character type variable is b. Then I have this float type variable. Right. So the memory allocation for this will be memory allocation for P. This will be memory allocation for A. A is an integer variable, that's why it will require 2 bytes of memory. So let's say memory allocated for A is on 1000 location. 1000 and 1001 contiguous 2 bytes will be allocated for A. Now memory allocated, the question we want to address here is how much memory is required for this pointer P, Q and R, right? So that's why right now I'm not writing how many bytes are allocated for P, right? So this is memory allocated for Q. In this memory we are going to store address of a character type variable because Q is a character type pointer, and let's say this is the memory allocated for this character B, which is 1 byte of memory, let's say on 2000 memory location, right? And let's say this is the memory allocated for pointer r, and this is the float variable c. Float requires 4 bytes of memory, so starting from 3000, let's say, to 3003, 4 bytes of memory is allocated for this c, right? Now let us store some values in a, b and c. A is equal to 10, b is equal to small a, and c is equal to 10.5. so these values will be stored in a, b and c. This is 10.5. right. Now let us store the addresses of a, b and c respectively in pqr. So let's say p is equal to and a, so I can store address of a in p because p is integer type variable, and p is integer type pointer, and a is integer type variable, so I can store address of a in p. So what I will store is the base address of a or starting address of a, right? So out of these two addresses we store the base address or starting address, which is 1000, right? Now let us store address of b in q. So q is equal to and b. So b is character type variable and q is character type pointer, so I can store address of a character type variable in character type pointer only. So I'll store this address. B has only one address, so 2000, right? Now in r is equal to and c. So c has 4 addresses: 3000, 3001, 2 and 3. Out of these 4 addresses, I'll store this base address, which is 3000. Now the point I want to tell here is, if you observe in all of the 3 cases, irrespective of the type of these pointers and these variables, we are storing only base address, no matter how many bytes are allocated for that particular variable, but we are storing only first bytes address. Here 1000, here 2000, here 3000. That means irrespective of the type of the pointer, we are storing only the base address of the variable, or only 1 bytes or first bytes address in those pointers. That means the memory requirement for all these pointers will be same. Whatever memory is required for storing the address, right, this address, whatever memory required for storing 1 bytes address, that much memory will be required for every pointer, for this pointer, as well as for this pointer. Now on 32-bit machine, the memory required for storing requirement for addresses is 4 bytes. So the pointers will require 4 bytes on a 32-bit machine. On a 62-bit machine, the memory requirement is 8 bytes. So the point I want to make is, the pointer variable requires 4 bytes of memory irrespective of the type of pointer. That means P will require 4 bytes, Q will require 4 bytes, and R will also require 4 bytes. So I hope you got the point. Thank you for watching.